Making feed silage for cattle for winter feed is a well-known and thoroughly researched process with known quality parameters. In spite of this, spoilage can sometimes occur, mainly through unwanted aerobic fermentation. Spoiling results in lower feeding value in the low range, or silage being unusable in the high range. Early detection of spoiling is mainly via an increase in sustaining a high temperature, with feeding value degradation at temperatures exceeding 30 degrees Celsius. In short, the project used long needle-like sensing rods produced by Quantury. These rods have multiple temperature sensors, and the data from different rods can be easily compared. The process can be described in 3 easy steps. Temperatures in the silage is measured by the rods and then sent via telemetry to the cloud as raw data. Additional data is collected from the Finnish Met Institute and integrated with the raw data. The resulting datasets are then analyzed in detail to identify trends and spoiling events. The farmer is then provided with enriched data and insights. The data is also fed into a 3D mathematical simulation model, which provides the farmer with insight on the volume and spread of suspected spoiling in real time. The farmer therefore has access to insights on the quality of the silage, which enables the farmer to make informed decisions to better manage the farm and increase profit. We have been able to observe limited volume spoiling in the silage stack. In this graph, the temperature in the top layer of the silage increased for a sustained period. From the data of this one rod, we can also conclude that the spoiling only occurred in the top layer of the silage. The 3D model also indicates that the spoiling is limited to a very small volume. Temperatures in this event indicates that the silage has lost some, but not all, of its nutritional value. Additional events, such as rainwater ingress into the silage, has also been observed. In this graph, sharp temperature decline in the silage is observed in coincidence with rain events. The 3D temperature distribution is solved using MATLAB. The silage is homogeneous and the isotropic temperature conductivity coefficient is 0.0461. The silage is insulated, in other words the edges has no significant impact on temperatures in the silage. The temperature distribution is calculated within the volume based on conductivity only. A clear rise in temperature compared with background temperatures is seen in the light blue and cyan color contours. Lastly, forward modeling were used to estimate the efficient distribution of the temperature sensors. We have observed the following phenomena that contributes to spoiling. Animals have a profound impact on the silage covering integrity. In this case, multiple holes made by birds in the silage coverings were observed. The highest temperature excursions were observed where the silage has not been properly covered with hay. It allows the silage to breathe during normal diurnal temperature changes. Weather may have an important role in localized spoiling, especially when the stack is young. An example of swamping on the silage stack is shown. Another part of the Good for Cattle project deals with new antimicrobial peptides and is carried out by the Unit of Measurement Technology from the University of Oulu, located at the Kajaani University Consortium. The excessive use of antibiotics is a huge problem in global agriculture, and the discovery of any new effective antimicrobial compound is important for industry. Antimicrobial peptides have one remarkable advantage. It is difficult for microbes to develop resistance to them. The peptides used in the project were discovered at the University of Oulu at the Department of Biology and have been patented. The spin-off develops catheters coated with antimicrobial peptides, which is resistant to biofilm-forming hospital bacteria. The project is testing the efficacy of peptides against various pathogens, synergistic or inhibitory effects of other compounds, and screens for the best formulation giving the best stability for peptides. The Good for Cattle project aims to develop applications for antimicrobial peptides in agriculture, with the first target to prevent mastitis by teat disinfectant. If you are interested in knowing more, please contact Tuija Kallio at the University of Oulu.